Hey, happy whatever today is, folks, depending on when your class meets. This is Mr. Murphy coming at you. I do apologize. I came into contact with someone who tested positive for COVID. Therefore, I'm going to be out all week. Hopefully, I'll be able to see you again next Monday. But you know what they say, the show must go on. So the plan was to review with you today, and then the test is going to be happening later this week, Thursday, Friday, whatever day your class meets again. If I was there, I would be checking to see who completed the review. So kind of as a compromise, I will still want this review sheet turned in on the day of your test. So don't turn it in today. Make sure you keep it to study for and ask questions. Those of you that were absent, this will be kind of a loophole for you. Or those of you that didn't do it, you'll be getting this here. So just make sure you're completing it or filling in any problems that you didn't do as we go through them here. Because when you come in to take your test, I will be asking the substitute to collect it from you. So we're just going to go through this one chunk at a time. This will really give you a good idea of what the test is going to look like. As far as I know, you will not be able to use any notes or any other resource sheets on it. So really make sure you get a handle on this. And if you do have specific questions or problems that you just really can't get the hang of, you're more than welcome to email me. If you don't want to dig through my Google Classroom, or excuse me, if you don't want to dig through to find my email, you can message me through Synergy or Google Classroom. But, you know, we are going to have everyone take the test when they come in. Those that are testing in the Learning Center will get you squared away with that as well. Anywho, away we go. Okay, number one, this type of one, it's shown up on some of the homework problems, and understandable, some students have had some questions on it. What I would do is I would just take what's written in the problem and make a little diagram on it. I'll try to zoom in so you can actually see it. But this is a representation of what they told me. They said, I've got similar triangles. I labeled them. I took the 16 and the 25 that they gave me in the problem, and I put that on their little side lengths. Down here, this is what I know about the perimeter. I was told the perimeter of PQR. I don't know the perimeter of this triangle. So that really tells you how the pieces match up. Once you have that laid out, one of the several ways you can go through and set up your proportion is take 25, match it up with 16, take the 75 and match it up with that unknown value. Again, not the only way to set it up, it's just the way that works for me. You're going to go ahead and cross multiply, which you guys have probably had to do several dozen times since this chapter started, and it should give you these two pieces right here. Blah, blah, blah. You divide both sides by 25, and that's going to give you that perimeter of 48. I don't think there were any units like centimeters or whatnot, so you don't have to worry about that. By the way, the test is going to be all multiple choice. I know you don't see that sort of thing very often, but you know, please make sure you're comfortable with the process, not just the whole, you know, taking a guess. Okay, feel free to ask the substitute to pause this as needed. We're just going to try to go through it because ideally you would have tried this review sheet already. Okay. Right here, we just sort of got a summary of, you know, what the criteria is for two triangles or any polygons to be similar. The angles in the first shape always have to be the same as the angles in the second shape. But as you've seen, the shapes can be different sizes. So the sides just have to be in the same proportion to each other. Angles are unchanged, but sides can shrink or stretch, excuse me. Okay. Here we got our lovely little triangular similarity postulates. We really went through a good chunk of these last week, but here they are again. You've got angle similarity. That means you see two angles in the first shape, match up with two angles in the second one. That's enough to say they're similar. Then we have side angle side. That's where they got one angle that matches, and then they've got two pairs of sides that are in proportion. And then third and final, we had side. That's where you take all three sides of the first one, and they have to be in proportion to all three sides of the second one. All right, try not to make you dizzy by swinging it back and forth like this. Whoop-de-doo. Okay. Number 4 was sort of a throwback to some of the notation that we like to review once in a while. They just want you to, come up with symbolically how to represent this phrase. So segment XY and segment PQ, notice how they both have those little bars on top of them, and then you need the congruent symbol in there as well. So you'll see one like that. I'm sure you're gonna be able to answer it without any issue. Number 5, just kind of a, I don't want to say a token one, but it did show up on one of the homework assignments. They're asking, hey, how many triangles are possible with whatever the given criteria is? They might just give you 1 bit of criteria, or they might give you 3 bits of criteria. But spoiler alert, it's pretty much always going to be an infinite number. We said earlier that similar triangles, they have the same angle measures, but their sides don't have to be the same exact value. So you can make it any size you want as long as the angles inside still fit that criteria. So it's usually a safe bet that it's going to be an infinite amount are possible. Okay. Next one, throwing the mid segments at you. I know a lot of people don't like this type of problem, but at least it's something you've seen before. So let me take it one step at a time. I've labeled what they gave us in the problem, and that relationship that we talked about said, okay, this little one, this mid segment, is exactly half the length of this bottom one. So I laid it out in terms of their segments right here. And then this next step, this is where I actually filled them in or plugged the expressions in. My first thought is to distribute the 1/2. There's other more technical ways you could go through it, but I'm just a creature of habit there. So half of 3 is 1.5, half of 25 is 12.5. You temporarily have decimals, but they're going to go away in a minute. Okay, from here, there's probably 4 different ways you can proceed. I went ahead and just subtracted 1.5x from each side. You could have subtracted 4x, you could have subtracted 5, you could have subtracted 12.5, whatever works, as long as you're consistent. And I'm just going to bring that over. This is what we end up with after we subtract the 1.5x. We got this mess, we got the 5, and then we got 12.5 over here. From there, I'm trying to get the plus 5 out, so I'm going to go ahead and subtract that from both sides, which drops me down to this. Finally, I was too lazy to show it, but as you guys remember, you would then divide both sides by 2.5, giving you an x value of 3. Here's where you want to make sure you double check the directions, especially on the test though. If it just said find x, we'd be done. However, the directions were saying solve for GH, which is what I've done here. I just took the x equals 3, I plugged it in for GH, and that gave me that bunch of stuff, which altogether gives us 34. So your final answer, the length of GH is 34. Okay, awesome. Hopefully nothing new here, because it is just meant to be a summary of what you've seen previously. Moving right along. This little problem kind of buried in the middle. Technically, it's not something that you had to really answer. It's just something to be aware of. It says that know those 2 relationships here. So that goes back to the whole mid-segment thing. Let me just draw a quick picture here. Let's say we got AB and we got DF. Let's just call this C, I guess. So for that part that asks you, state the 2 relationships between the 2 sides, the one we've been stressing is the one we actually just used in that previous problem. But something like this, we would say the length of segment AB is equal to 1/2 the length of segment DF. So that's one relationship. The other one, I'm going to be a little lenient with this type of question on the test because I was stressing a certain one that I guess is not one of the big 2. But the second one is the whole fact that AB is parallel to segment DF there. So you'll be looking for those two relationships in the same problem. You should hopefully be able to get this one, but then that whole parallel thing comes with it. I'll be lenient on that if I didn't go about it the right way. Okay, moving right along. I think I might do these next few out of order, if that's okay. Or no, maybe not. No, scratch that. Let me just do it. Let me just do it in order here. Okay, number 7. It's very easy to make a mistake on this, but go figure, we're going to set up a proportion for it. So we've got these mid segments going on there, and it's a matter of matching up the pieces. You could think of it as one little triangle inside of a big triangle. I was too lazy to actually lay it out like that. But we could say, okay, the bottom of the little triangle matches up with the bottom of the big triangle. That's where it's 16/24 comes from. But then when you set up your other fraction, that's where it gets easy to make a mistake. We've got 10 as the left side of the little triangle, but we can't just put y down there. We need the length of that entire side of the big triangle. So that's why we need to think of it as 10 plus y, which is why it goes together like that. When in doubt, set up a proportion. From here, you might be off and running, but we're going to go ahead and cross multiply. 16 needs to be multiplied with all of this. That's why I put it in parentheses right here. And then 24 times 10 gives you the 240. You guys know as well as I do, too, that I'm not immune to making mistakes. So if you do think I made a mistake in one of my calculations, the sub might catch it, but if needed, somebody can just pop across the hall and ask Miss Rose Johnson to clarify. She's the master at this stuff. Okay, next up, I'm saying, all right, I gotta do some inverse operations. Forgive me if you don't need me to drag you through all those steps, but I'm used to also teaching Algebra 1 classes where we really need to stress those steps. So it drops down to this. You divide both sides by 16, and you get a nice answer of y equals 5. They did just say solve for y, so that's why we're done right there. Okay, awesome, great, grand, wonderful. Number 8. Nothing too sneaky here. You're just matching up pieces. I take something from the first triangle, match it up with something from the second triangle. These are both the outer measurements. That's why y and 16 can go together. And then I've got that middle piece of the top triangle matched up with that middle piece of the bottom triangle. So that's why we get our lovely little proportion like this. Blah, blah, blah. We go through and cross multiply. 12y, 16 times all of this. I really would encourage you to set it up like this, because if you try to skip this step with the parentheses, it's more likely that people make a mistake, including me. You distribute the 16, that gives you that mess. Inverse operations to get the y terms together. Then you divide by -4 to get y equals 12. Okay, feel free to ask the substitute to pause this as needed. I'm trying to make all this fit in an hour. I'm aware that most of you already went through and did this. Okay, anywho, technical difficulties aside, let's see what's shaking on number 9. Number 9 is pretty much a retread of that previous one. Here's the only thing that might be sneaky. It's kind of like they took this top triangle and rotated it down to get that bottom triangle. So that's why the 4 actually pairs up with the 7, because it's the slightly longer side of the top one with the slightly longer side of the bottom one. So if 4/7 go together, then it's easy for you guys to figure out that y plus 2 goes with 5. So here's our little proportion, and then you attack it just like you did before. I don't have anything real magical or new to say about this. You distribute, you would subtract 14 from both sides. It gives you this mess. Here's where you get something that we don't run into very often. That's when you divide both sides by 7. You don't get a very nice answer. Decimals are okay on occasion, but this one divides out to a horrendous decimal. So I would just go ahead and keep it as a fraction. On your test, what you'll see is, some answers are listed as decimals, some as fractions. So just be aware, if you crunch it out and make it a decimal. You go through and look at your answer choices and you say, oh, I guess there aren't any decimal answers, so just pick the equivalent fraction. Okay, number 10. Try not to get the last one totally out of view just in case you need it. But number 10, more parallel stuff here. This is probably not the only way to go about it. It's just the way that jumped out at me there. We could say, all right, the top of the pizza slice goes with the crust piece, and then same thing over here. Top of this one goes with that one. So this is just a setup I came up with. If you did it a different way, just see if your answer comes out the same thing. Or if you're doubting the answer completely, just check with Ms. Rose Johnson, and she'll be the tiebreaker for you. You distribute, gives you this mess. You let's see, you would add 32x to both sides. Then finally, you would divide both sides by 48, and that gives you what we know and love, that whole nice answer of x equals 8. Those ones typically are just asking you to find x or y. You shouldn't have to plug it back in to anything. You just find x, you find y, or whatever, and you're done. Okay, pause if needed, but we're just going to keep on cruising. All righty, 11 and 12, these are all tied to that same diagram, and it'll be the same way on the test. Just make sure you're reading it carefully so you know exactly what they're looking for. Total honesty, I wish they would always ask for the scale factor first before asking you to find one of the variables, but on the test they might switch those around. Just know that, in my opinion, whichever order they ask it for in, I would say probably find the scale factor first before you backtrack and do anything else. Anywho, if they want us to find the scale factor, remember that has to be done in a certain order. You take something from the prime triangle, which in this case is the big one, and put it over its matching side or corresponding side from the regular triangle. The only two numbers you can match up is 12 and 5. You would reduce that if you could, but 12 over 5 can't be reduced. Speaking of that, they also want what kind of dilation it is. Well, the prime one is always the new one, so if it started as this and became that, it's going to be an enlargement instead of a reduction. Okay. As for finding the variable, this is where you just go ahead and match up some sides. We said earlier that 12 matches up with one of the 5s, and then y is going to match up with 4. Hence, this is your proportion. 12 over 5 equals y over 4. You go ahead and cross multiply, and then you would divide by 5. Once again, we get a fraction that doesn't work out nicely. On the test, they're probably going to leave it in fraction form. Certainly look to see if you can simplify it or reduce. Otherwise, you just kind of leave it as is. Okay, that's really the bulk of what they're going to be doing with scale factor directly. Feeling good, everybody? Okay, well, I have to assume you are, since sadly I'm not there. Lucky number 13. Yes, it's a word problem, but the good news is they've done most of the labeling for you. We've got a flagpole, we've got a student, and then the sun is shining down on both of them, forming a little triangle inside of a big triangle. They want us to find the height of the student, which is why our X goes right here. Same old, same old. There's probably 4 different ways you can set up the proportion. What I did this time is I did something from the little triangle over something from the big triangle. So I did X over 30, and if I did it that way, I have to be consistent and do 12 over 66. You could have done 30 over X, but if you did 30 over X, you then have to do 66 over 12. Basically, most of the ways you do it have X and 12 in the same level and 30 and 66 in the same level. You cross multiply, I know, big friggin' surprise, gives you this mess, and then you divide by 66, which if I did it correctly, came out to this many feet. Feel free to double check it, or if you think it's wrong completely, you guys can brainstorm on that. Most of the time it'll be a nice answer. However, there are exceptions like in this one. Okay. 14. Yeah, this one, I'll be honest with you, threw me off a little bit. And here's why. You might be looking at it saying, well, there's really no reason to be thrown off. All the labels are there. I had to check with Ms. Rose Johnson on this, and it was set up this way on purpose. Notice how some of the measurements are in inches, but then they also give you feet, which means we can't set up the proportion until things are converted into the same units. What I did is I put the 2 over the H. That part you're pretty much familiar with. And then here's where the sneaky part is. 6 was measured in inches. That's why it just went right in. But 29 is measured in feet. We have to quickly convert that to inches, which is what I did over here. 12 times 29 to give you that many inches. That's why 348 ends up on the bottom there. Okay. Other than that sneakiness, the rest is going to be the same. You cross multiply, you get this stuff, you divide by 6, and you get 116 inches. The problem didn't specify whether it wanted the answer in inches or feet. I just went ahead and put it in inches. The test should be a little bit more clear than that. And spoiler alert, I don't think you're going to have anywhere you have to convert feet to inches or anything like that. This was just a little above and beyond example that I think we took from one of the state tests. Okay, sneakiness, no shortage of it. 15, that's another review type question. They're asking you, find the value of x that makes these lines parallel. Well, the rule is if lines are parallel, these alternate interior angles are congruent. That's why you just take them and set them equal to each other. From there, you just rely on your usual inverse operations, brings you down to this, more inverse operations, and then you get good old x equals 25. So just set them equal to each other and solve for x. I know, whoop-de-doo, right? Just pausing for a moment because I went through that kind of quick. All right, once you have it set up, though, I'm sure you're going to be ready to roll on that one. Feel free to ask the substitute to pause it, whoever that kind soul is who's covering for me. All righty. 16 through 19, they're asking you, are the triangles similar? And if so, by what postulate? Remember, your 3 postulates that you have to choose from. I'm just going to write them up here again. You've got angle-angle similarity. You've got side-angle-side similarity. And then you've got side-side-side similarity. The sides have to be in proportion, but the angles just have to be congruent. All righty. I've got one pair of congruent angles in number 16. They're both 90. And then if you were to subtract the known angles from 180 degrees, meaning if you did 180 minus 90 minus 60, you'd find that that's 30 degrees. And you'll notice there's another 30-degree angle right here. So we have a pair of 90-degree angles. We have a pair of 30-degree angles. Technically, we also have a pair of 60-degree angles. But once you have 2 congruent pairs of angles, that's enough to say, yes, they're congruent by angle-angle similarity. Spoiler alert, if all they give you are angle measurements, it's a pretty good bet that it's going to be angle-angle similarity. 17, notice they're giving you angles and sides. So that'll be a little spoiler that it's going to be side angle side similarity. However, we don't just want to assume that they're going to be similar. We also have to make sure the sides are in proportion. We got a congruent angle, we just have to see if the sides are in proportion. So 3 matches up with 12, 4 matches up with 16, and the fact that they both simplify down to the same thing, that's what tells us that the sides are in proportion. Therefore, we're going to be able to use side angle side. Okay. 18, going off that same notion, notice they give you angle or a pair of angles and sides. So you might be tempted to use the same reasoning we did last time. However, when we try to match up the pieces, 10 with 18 and 9 over 16, they don't simplify down to the same thing. Therefore, these are going to be, nope, they're not similar because the sides are not in the same proportion. 19, back to more of the stuff we love. They're telling you stuff about sides. And this angle M, they actually both share that angle. Notice it's a part of the little triangle and the big triangle. So that's going to be enough to say, yes, they're similar because their sides are in proportion and one of their angles is congruent in both. Oh, darn. Try not to get too sad, but we're actually almost done. He's got a couple proofs to look at. Yes, I know. Everyone's favorite thing, proofs. There might be some variety in how you do these proofs. Usually with these similarity ones, we try to really gear it towards specific steps. Okay, I'll try not to, shift the paper all over the place. I'm trying to make it so you can actually see the diagram too. All right. For the given, that just gets copied over into your first step. That's saying that certain side lengths match up with each other, certain side lengths are in proportion to each other. And of course, the very first step is given. What they're probably going to do on the test is they're going to make any proofs into multiple choice format, meaning they're going to say, here's the correct statement, choose the correct reason from a certain list. So you'll at least know that the first step is given. Step 2 or statement 2, we just got to figure out where these angles are, and I would go ahead and mark them accordingly. Those are vertical angles, which is why the reason is that, if you have vertical angles, they're always going to be congruent. Last but not least, the reason we're able to say that these triangles are similar, they told you stuff about two pairs of sides in the given, and then we were able to say something about one pair of angles. So the only postulate that matches that, two pairs of sides and an angle, is side angle side similarity. Nice short proof, nothing major. There's not going to be any 7 or 8 step proofs. I know, so sad, right? Okay, last one, a little more fill in the blank. We'll try to ease you into this if you can't read my writing. Oh, big friggin' surprise. Step 1 is given because that's what was listed right here. They've already got that marked for you. That's what that little arrow set means. And there might be a few different ways you can approach this next step here. You could have multiple things listed. But what jumped out at me is that this angle that's in the sort of lower left of the little triangle, I should call that angle JKN, just so it's really clear which one I mean. We could say that that's congruent to angle L right there. They're both in the bottom left of their respective triangles. So that's what this step says. Angle JKN is congruent to angle L. And that's because, like we said, they're both in the lower left of their respective triangles. So we call them corresponding angles. Where one is corresponds to where the other one is. Statement 3, that may look like a typo. We talked about it a little bit last week, but whenever they say something is congruent to itself, that's an example of the reflexive property. So that's what I went ahead and did. I marked it with those 2 little slashes or arcs to distinguish it from this one. And that's saying, okay, angle J is part of the little triangle and the big triangle. But whenever something's congruent to itself, it's going to be the reflexive property. Now that you have that laid out, think of the little triangle. You've got an angle and an angle marked. And then if you think of this as one big triangle, you've got this angle marked and you've got that angle marked. So we're ready to say that the 2 triangles are similar to each other, just like it was asking you to prove. And the reason is that they're angle-angle similarity. Okay, hopefully that clears up any lingering confusion that you had. No, this is not the easiest stuff in the world, but I think you're going to do fine on this test. If you do have any questions for me, message me through Synergy or through Google Classroom. Even though I can't be there, I will, be available to respond as needed. In terms of what I'm going to ask from you guys, you might have the same sub, you might not, but when you come in Thursday or Friday to take your test, that's when I'm going to ask you to turn in this completed review sheet and, of course, where the heck was it? And, of course, this little 6.5 proofs assignment. as well. I'm just going to have the substitute gather up anything on paper that you're looking to turn in, and as soon as I'm able to come back, I will go through it, update your grades accordingly there. Thank you for your time, everyone. I will see you as soon as possible. Take care, everyone.